Hello class, welcome to week 3 of distance learning. Today we are going to talk about percentiles and quartiles. As you can see, I do not have any whiteout at home. Anyways, let's start by reviewing what a median is. So let's find the median for the following set of data. Now the median is the middle number from an ordered list. So we have to take this list of numbers and we have to start by ordering it from least to greatest. So the smallest number is 3, followed by 6, 9, 13, 19, 30, 34, and 39. So we can see here that we've got 1, 2, 3, 4, 5, 6, 7, 8 numbers. When we have an even number of numbers in the data set, there isn't one single middle number. So what we do in this case is there are two middle numbers. We're going to find the mean of those two middle numbers. So we're going to add the 13 and the 19 together, and then we will divide it by 2. So 13 plus 19 is 32. 32 divided by 2 is 16. So therefore the median is 16. So if there was an odd number of data, you would just pick the middle number after ordering it. So it's important to make sure you order the numbers from least to greatest before you start. The media, as we can see right now, often reports statistical data. It is important for us to be familiar with the statistical language that they use. So we're going to talk in this lesson about percentiles and quartiles. So here's an example. Here's the state of Florida, and this is showing groundwater levels in percentile ranks. So any location with a star, it means that their percentile ranking in the wells is above 90, which would be above normal. So there's a few communities here with these stars. The triangle means that their percentile ranking is from 76 to 89. So then there's this in these areas and so on. Okay, so what we're going to talk about is, what does this mean, having these kind of percentile rankings? So a percentile is the approximate percentage of data that lies below a particular value. It is a good way to rank data or compare data. Okay, so for the state of Florida, for those communities that have the stars where it's over 90%, they're in a much better situation with their groundwater levels than the ones with boxes, for example, that would have their percentile rankings is between 11 and 24. It may not mean that compared to the other parts of the United States that it's great, but compared to these other locations, it's better. So, for example, if your grade was in the 80th percentile in 12 college mathematics at Banting, that would mean that 80% of the students taking 12 college math at Banting have a grade that is lower than yours. Quartiles. Quartiles are the three values that divide a listed number into quarters. That's where the word quartiles is coming from. To calculate quartiles, you must first list the data in numerical order from least to greatest. It is easiest to first find the second quartile, which is simply the median of the entire data set. The first or lower quartile is the median of the lowest half of the data. It separates the lowest 25% of the data, so it is the same as the 25th percentile. The third or upper quartile is the median of the highest half of the data. It separates the highest 25% of the data from the lower 75% of the data. Thus, it is the same as the 75th percentile. Okay, you'll see this better with our next example. So here we have the hourly rates in dollars of 15 students who have part-time jobs. And we want to calculate the quartiles for this data. So step one, when you're doing this, you want to carefully list the data from least to greatest. Now I did this for you. Okay, so I took the numbers and I rewrote them from least to greatest. Your second step is to find the median, which would be the second quartile. So we know that there are 15 students on this list, so I have 15 data points. If you didn't know that, you'd have to count it out. And when I have 15 values, my middle number will be the 8th value. So I'm going to count out from the this organized list where I've listed things from least to greatest. So make sure you use this list, not the original data. The ordered list needs to be used. So I'm going to count out the 8th value. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So my 8th value is that number 14. Now I'm just going to double check, make sure it really is the middle number. So I should have 7 values on the right side and on the left side. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. So that really is our middle number here. So the median, which gives me my second quartile number, is 14. That was our starting point. So here I have quartile 2, or the second quartile, and I started by finding that first median. Our third step is to examine the lower half of the data, of the ordered data, and find its median, which would be the first quartile. So over here, this would be the lowest half of the data. Now, if I had an even number of points, when I do my lower half and my upper half, they would be kind of side by side. This time when I do the lower half, it won't include the 14. And here's my upper half of the data. Okay, so let me just jot this down for you. So there's the lower half, and this is the upper half. So again, if there's an even list, it would look more like this. You wouldn't have this number in between separating the lower half and the upper half. Okay, so now what we're going to do next is we're going to find the median of the lower half of the data. So here I have 7 numbers. So my median of the lower half is at 1390. So I just want to double check. I have 3 numbers below it and 3 numbers above it in that lower half. So that is the median of the lower half. So that is quartile 1, that number. Okay, and I'll jot that down for you. So this number comes from, it's the median of the lower half of the data. Okay, so again, that number was the 1390. Step 4, we're going to examine the upper half of our list, and we're going to find its median, which would be the third quartile. So when I take a look at this list, here's my upper half, those values here. I'm going to find that middle number, so it's going to be the 4th number. I'm going to double check. There's 3 below it, 3 above it. It really is the middle. So this is quartile 3. And again, that was found because it's the median of the upper half of the data. And once again, you must work with the ordered list. You cannot work with this list where the numbers are not in order. Okay, so let's just use this little plot here to jot down our answers. So we started with the median of the entire data set, which gave us the second quartile. Okay, then we examined the lower half of our list, and we found the median from that lower half, which was the wage of $13.90, and that was the first, which could also be called the lower quartile. And then we examined the upper half of our data. We found that middle value, the median, which was $15.35, and that's the third or upper quartile. Now you could list all your numbers in this graph. You could put all these lower numbers up until the first quartile, and then put your next values here up into the median or the second quartile, label your next set, plot them there, and your last set here. So then your numbers would range from the $13.15 wage up to the highest wage of $17.50 for this group of students. Okay, let's do some more examples. So Shannon gets paid $16.70 per hour. What percentile does Shannon lie in this list? Well, we want to use this formula for determining percentiles. So this formula says this: a percentile for a particular data value x is equal to the number of scores below x plus 0.5 times the number of scores equal to x divided by the total number of scores times 100. Now, so if let's say Shannon got paid $14 instead of the $16.70. For this part of the formula here, there's 4 values of exactly $14. So in this part of the formula, I would do 0.5 times 14. Okay, that's why, because sometimes we have these duplicated score values. Okay, so for Shannon's data, the number of scores below her $16.70, we're going to count it out. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There were 13 scores or values that are below x. So it's 13 plus 0.5 times the number of scores equal to x. So x here is the 1670. So it's times, there's only one score or value of $16.70. So it's 0.5 times 1. All over the total number of scores, which is 15. And then I'm going to multiply that by 100. Okay, so 0.5 times 1 is just 0.5, plus 13 gives me 13.5 on the top, divide by 15. And when I work this out on my calculator, I get exactly 90. So you won't always get exactly a particular percentile. You might have a decimal number as well. So this means that her pay is in the 90th percentile. So what does that mean? That means that approximately 90% of the students earn less than Shannon. Okay, so let's do C. If Travis's pay is in the 65th percentile, what is his wage? So to determine this, what we want to do is we want to take our 65th percentile and we want to write that down, the 65% as a decimal. So I get 0.65 when I write 65% as a decimal. I'm taking the number and divide it by 100. And then I'm going to multiply that by the total number of data. So there are 15 pieces of data in this list. And 0.65 times 15, when I put that in my calculator, I get 9.75. So what we do next is we're going to round down. So we're going to round down to the number 9. This means that 9 students earn less than Travis. So Travis, or Travis's wage, is the 10th wage on the ordered list. Okay, so let's count it out. We're going to go back to our list, not the top one because it's not in order. We're going to go to our ordered list and we're going to find the 10th wage. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that wage there, the $14.50, is Travis's wage. So we're going to write that down. So therefore, Travis earns $14.50 per hour. Okay, so let's review other measures of central tendency. So a median is one measure of central tendency. Other measures of central tendency include the mean and the mode. And all three measures of central tendency are beneficial in different examples. So remember, to find the mean, what we want to do is we want to add up all the values on our list and divide by the number of numbers. So the mean, we're going to sum all the values, and then you're going to divide by the number of values. So on your calculator, remember to hit pause to do the work on your own. You're going to add up all the numbers on our list. You can use either list, it doesn't matter, this one or this one. And then after you find that sum, divide by 15. So you should have gotten $218.55 as your sum. And when we divide that by 15, we get a mean hourly wage of $14.57 per hour. The mode is the number that occurs the most. The mode is 14 on this list. That's the number that occurs the most. Now you might want to think about why. Why would the mode be 14? I believe that is adult minimum wage, so it would make sense that maybe the 14 occurs the most. So in this case, the mode is $14 per hour. Okay, that's it for this lesson. There is another example that I would like you to see, but you're going to do this on your own by going to the website Math is Fun, and I put a link on the news item of the D2L. So that example, or when you go to Math is Fun, it does another example with quartiles. So it will have one example that's similar to this one, only there's fewer numbers, so it's faster to get through. And then the second example has an even number of data points, so that even number of data points might help you with some questions if you want examples that look more like particular lists in the homework where there's an even number of points. Sorry, I'm distracted with the background noise in my house here. Okay, anyways, that's it for this lesson. Get your homework done and then do the next question or the next lesson.